In this video, we're going to talk about the three key pieces of software needed to run and compile and simulate VHDL code successfully. So the first thing we need is a text editor. It's very simple. We need a text editor because we need to be able to write our files. So text editors come in very different shapes and forms, and we can have very simple ones and very advanced ones. So you get to choose whichever text editor you prefer, or if you choose a specialized programming IDE to write your code. After the text editor, we need a compiler, because VHDL code is compiled code. It needs to be compiled in order to be executed. So we need a compiler simulator. So this is very important because this will give us an executable or an executable form of our design. And from that, we need a third piece of software, which will be a waveform viewer, which will allow us to graphically examine the behavior of our systems. So we need these three pieces of software in order to successfully run VHDL code in any computer. So the text editor is very simple. We can leave that as simple as a notepad. For the compiler and simulator, depending on the type of toolchain that we are using, it can come to, and same as the waveform, they can come together or in separate ways depending on the tools that we are using. If we are using Vivado, compiler, simulator, and waveform viewer come together in the suite. This is a great plus for Vivado. If we are using EDA Playground, it's online, so everything comes included. As a matter of fact, with EDA Playground, we get to choose from different compilers that we can use, and that is a great plus. And there is another category that we will also examine, which is the open source, the open compilers, which in this case, it's called GHDL. And GHDL, it's a standalone program that will compile your VHDL code. It will simulate it, but it won't show you a graphical view of the waveform. So we need a third piece of software, which is our waveform viewer. And in this case, for our waveform viewer, we will be using something called GTK Wave, which will allow us to basically capture the output from the simulation and the compilation, or the compiler from the executable form of our design, and turn it into a waveform that we can analyze graphically.